a quick little review of the intermediate value theorem, chapter 1.4 in our textbook. And here's basically the idea. Okay, so we have a definition. It states that if f is continuous, remember, a continuous function must be continuous. There's no holes, there's no gaps, there's no place to jump or go anywhere. It's continuous on the closed interval of a to b, including those numbers. That's closed, right? It's not like negative infinity or positive infinity, where those values cannot be defined. These are definable points, a and b. So long that f of a does not equal f of b. Why would that be the case? Well, if we had f of a equaling f of b, that would mean that those two y values are the same, and we would no longer pass the vertical line test, hence not a function. So it would break some other rules there. And k is some value that is any number between f of a and f of b. So in between those two y values is what we should find. If those things happen, then there is at least one number c in the interval. So c will be an x value, just like we do with limits, in the interval from a to b, such that f of c will equal that k value. All right, well, that's a lot of words. Let's see what it means and it looks like in pictures. So here's your a value. And as we notice, the blue line is our function. And so as this goes here, we can see that if we put in a to the function, we follow it up, and at that y value, we will get f of a. Okay? If I put in b, again, b is included. This b is definable. If I go up to the function, follow that over, that will be my y value, or f of b. So it basically states that if those things happen, we can choose any value between f of b and f of a, choose some k value, and if we do that, follow down here to the function, go straight down, and that will be some c. And if that c is a valid point, then it will be absolutely between a and b. Intermediate value theorem. So intermediate meaning in between some values. It's nothing more than that. Let's see a case that doesn't quite fit the bill. Here we have interval a to b, and we have a jump here, right? We go from one y value to another, where this is a discontinuity. It's a discontinuous function. Although we get a value for a, and we do get a value for b, in between that, if I choose some random k inside here, that k might be such that it completely skips all the values and doesn't ever touch the function, and therefore it won't ever create a c value. All right? So in the case of points of discontinuity, where it's undefined, or you've got a major jump like this, then that k value may not be or will not be defined to gather a x or a c value. All right? How do we do it in real life or in math class? Well, here we go. Let's look at an example. If we look at the example of, I'm just going to put that right there. I guess I'll hold it up. Okay. If we go, example 1, f of x is equal to x cubed plus 2x minus 1. Use the intermediate value theorem to show the polynomial has a zero. Has a zero. Remember, a zero is where the function crosses the x-axis. To show the polynomial has a zero on the interval of 0 to 2. So what I've done is I have plugged in from 0 to 2. So 0, what do we get when we plug in 0 to the function? Well, 0 cubed plus 0 is negative 1. If I plug in 1, 1 cubed is 1, plus 2 times 1 is 2, so 1 plus 2 is 3. 3 minus 1 is 2. If I plug in 2, 2 cubed is 8, And 2 times 2 is 4. That's 12. 12 minus 1 is 11. So we get f of 2 is 11. So it wants us to verify that there is a 0. Well, a 0 would mean that we're going to cross the x-axis. Now, watch. If I take off from this 0, and I'm supposed to get to this 2 value, right? Well, I absolutely have to cross the x-axis, because I can't go up and go, oh no, I can't do it, I'm afraid. And I go over here, and then I want to go up again. Oh, I can't, I don't want to cross the x-axis, I can't, oh no. And then maybe I try and sneak around 2 and go up. But then I got to go back over here to get to 2, and then I'd have to go all the way up here. Well, guess what? You just broke the fundamental rule of a function. It doesn't pass the vertical line test. So that we don't do that, right? It doesn't happen. The only thing it can do is go from this spot here and cross through the x-axis and then go up to the y, right? So this is a cubic, so we know it has some shape. It might be doing something else elsewhere, but on the interval from 1 to 2, it must cross the x-axis. Anyway, hope that helps. Have a great day. Talk to you soon.